Good afternoon, ladies and gentlemen, and welcome to the fourth edition of DC Dialogue. My name is Surendra Balakrishnan, and I'm the editorial director of CPI Industry and editor of Climate Control Middle East magazine. This edition of DC Dialogue was intended to be hosted in Dream Island in Abu Dhabi, but COVID-19 sadly disrupted the schedule, and here we are, forced to talk to one another in virtual space. The topics for the Dream Island meeting were quite different. COVID compelled us to revisit the topics, so we shall be looking at the implications of the pandemic for the district cooling industry, including the utilities. At the same time, we shall be addressing the conventional topics of discussion, including optimization of plant rooms and water treatment measures. And with that, ladies and gentlemen, it's my pleasure to introduce you to the chair of this webinar. And he is George Berbari, the CEO of DC Pro Engineering. George is also a pioneer of the district cooling industry in the UAE and the author of the critically acclaimed book, The Energy Budget. In short, we are in the very capable hands of an expert. Ladies and gentlemen, I present to you George Berbari.
Thank you, Surender. And welcome, ladies and gentlemen, as well, to quite challenging time, not only to district cooling, but to all our businesses, probably. However, I would say it is less severe than 2009 to most of us, but we see big changes in our industry. Part of that changes is we are seeing a trend of consolidation of district cooling industry. A lot of acquisitions that we will see in the plenary discussion. We will share some info about that. We also have a challenging hospitality industry, especially in Dubai, which was a main industry. Most of the hotels are barely operational. Some of them completely shut down. And many are connected to district cooling, and there is difficulty in paying the demand rate bill. We'll also talk about that later. However, I mean, these are the urgent challenges that we faced. On long term, we see a stronger and stronger solar energy getting into the energy mix picture at unprecedented rate, even breaking the 1 cent barrier in Abu Dhabi. And we see that our industry play a key role in energy storage that's in medium term, and which is not really till now benefiting from it. We need to prepare our industry to integrate with increasing solar energy movement that is coming. That concludes my welcoming address note and set the tone probably for what to come. We have an important preliminary discussion panel, impressive panelists, also highly experienced. And I want to start introducing them one by one. Mr. Bill Hutton, Manager of Corrosion Solutions Structural Technology. Bill Hutton is a manager of structural technology, longer solution team based in UAE, and his capacity is leading durability related repair works for reinforced concrete structure, which include structural and static concrete repairs. You know how critical that is for our cooling tower basin, and also post-tensions repair, water intrusion, and moisture mitigation strategy. The second speaker is our panelist, Mr. Sagar Kulkarni. He's a managing director of Consistent Engineering Consultant. He has extensive experience in HVAC arena. He's a mechanical engineer with over 26 years experience, particularly in green buildings implementation. Our third panelist is Mr. Dominic Mcpolin, always from Bahrain. He's a Chief Central Planning of Ministry of Works in Bahrain. He has been on many panel discussions with us in our industry. and he is the Chief of Central Planning at Ministry of Work of Bahrain. He is a chartered town planner and with 2 degrees in city planning, specializing in infrastructure. He is also a chartered planning and development surveyor. Now, our fourth speaker is also a known person to us, Mr. Sagar Kulkarni. He's a managing director of Btu and Engineering Services. He's a mechanical engineer with more than 36 years of versatile Gulf experience in design, supervision, and project management in building services and infrastructure. And last but not least, my good friend, Mr. Reddy, is managing director of Alexander company. He has extensive contracting experience in our industry, particularly industry cooling, where he has probably completed more than 3.5 billion dirham of projects value. He is an innovative and result-driven leader focused on achieving exceptional results. By that, we cannot hear the clap of the audience, which we miss. Normally, we welcome them with a clap, but now we welcome them virtually to our panel and start our preliminary discussion. We will start, the first point is the consolidation. And by that, I would like to share with you a quick slide that I prepared regarding our consolidation. Let me see. Too many open. Anyway, while speaking, we can talk that there is over 9.5 billion dirham of consolidation that happened in the last period. And more to come as well. Sorry for that. Let's skip the sharing of this screen for a moment, and when it comes, I will show it back again to you. Mr. Reddy, since you are there, what do you think of our consolidation that's happening nowadays in our district cooling industry?
Good afternoon, everyone, and thanks to CPI for organizing this very interesting webinar, and hopefully we'll work out something with some points which would help in the current situation. Mr. George, good afternoon. And yeah, okay. Just to answer your question, in terms of consolidation, it's more or less very well defined, because I think.
Can you see the screen now?
Yes, please.
Can you see my screen? There is Excel sheet with the consolidation that happened only in UAE. We have 9.2 billion dirham of consolidation that happened in the last 6 years.
Right. So, in fact, I think the real players are in the field now, more than, because not that the others were not up to speed, but it's a question of how they can sustain through the difficult times. Since the district cooling has come as a requirement or as a essential media in part of this, of course, Dubai has been always in the forefront. It went through a lot of rough patches, 2008 to 2012 to be precise. And again, the latest situation again calls for a bit more consolidation, and definitely it is going to change hands. For sure, it is going to change hands. And definitely people are looking for a much more customized and cost-effective solution-based plants. Earlier, the plants were are done more on a futuristic approach. Now it is a question of how you are going to make the plants self-sustain and also deliver what is required to the end user. In terms of the numbers, Mr. George, I think you put in a very I think it tells all. It is very clear how the plants are changed hands. And for sure, I think there'll be a handful of people only who will be in a position to manage these plants. And definitely there's a way to go, because the single owners or the single property, what do you call this, the developers, having such a magnitude of a plant or size of the plant may not be commercially viable in the future in terms of the capex, as well as the we're talking of in terms of the OPEX as well, that is the operating costs. So as what we see, again, I'm talking in terms of UAE in particular. I think the best we can see is maybe around 2 to 3 operators in the near, rather the district cooling operators in the near future. That's my take, Mr. George.
Who else, Mr. Sagar, would you like also to see? I mean, will that enforce more monopoly? Will this put the end user more at mercy of these mega district cooling operators?
Sure, George. Earlier we were talking about the expansion. A lot of projects were coming in. The occupancies were very high. And we talked about district cooling when the occupancies are dense occupancies in a given area, which will make the model feasible in terms of the economy as well as legalities. The moment we have large district cooling plant, less occupancy, we have multiple challenges in technical terms of load density, where the load is not there, and then the corresponding aspects, which also puts the pressure on the economic side when minimal charges has to be made. So when you look at the model as sustainability, if the population goes down, it poses challenges. Now, with current scenario, if you look at it, we can see a reverse migration all over. People are going back to the countries, from the countries it's going back to its towns. So having such model, we have to really look into reducing cost is one of the aspect, but then bottom line becomes sustainable. Sustainable in terms of environment, sustainable in terms of society, and sustainable in terms of the economy. So as a whole industry, we need to think and evaluate what exactly can be done and how it can survive. Today we are talking about survival mode, forget about expansion.
Maybe Prabhakar Naik can respond to that.
I will.
You think is this good for the end user to have? We have 2 now mega district cooling companies with 1.4 million ton, both of them almost. Is that really good to the end user, or will this reduce his negotiation power?
Actually, in one way, if you look from the country perspective, it is good, but then it is a monopoly and dominating, because the charges being levied by these people are quite high. And couple of projects in Sheikh Zayed Road, though there was Tabreed existing, I myself designed a standalone system for 2 projects. One is Aspen Commercial and 21st Century Tower. You see, even though central district cooling was available, I designed my own standalone water-cooled centrifugal chiller, because the charges were quite high and the benefits were not passed on to the end user by the utility provider. This is the main reason.
Okay, Mr. Dominic Mcpolin, how are you? The hospitality sector nowadays is suffering horribly. I mean, not even barely functioning at all, and many of them connected to district cooling are not capable of paying their bills.
Could I comment on the consolidation issue?
Sure,
yes.
sure.
I think this is a symptom of an immature market, actually. We are dealing now with a new destination for financial investment. and it's very attractive. Capture of customers locked into contracts, very attractive for the finance of these growing monopolies. This is a government issue. You've heard me say this 100 times. This is a government issue about regulation, a regulation of how this industry is going to grow. And one of the issues is this danger of monopoly. Instead of this, there should be control over these transactions by the government to ensure that there is.
Can I request the panelists who are not speaking to us to mute their phone? Maybe please, can you mute your speaker so that Dominic is not interrupted, if you don't mind.
Thank you. The big one that we are interested in Bahrain is interconnecting systems. If we had the regulation to allow companies to interconnect, we would have a different type of model operating here rather than a buy and sell consolidation model. If we have regulations on the coexistence of different companies competing in the market with competitive terms, we wouldn't get, like the last speaker has just spoken,
Dominic,
the industry.
I'm sure you are aware of the district cooling regulations that came in Dubai, Abu Dhabi, and Qatar,
Yes.
and now a little bit in Saudi Arabia. And you see all of them are shy regulation, call them soft regulation. So the government is afraid to step in with hard feet, and there is no protection for the end user or to have this common network because you need a neutral entity where multiple operators can connect to a neutral network, like the electric grid in the US.
This is what we are attempting in Bahrain. We've gone through the first stage, presentation to cabinet. It's now being translated into Arabic. And we will try a harder regulation, consumer protection, an industry protection, an energy performance protection, and most importantly, transparent tariffs.
Sure.
One of the big issues that happened with COVID is actually we gave a 3-month tariff holiday across Bahrain. And what that exposed the district cooling companies, because of exactly the second question you asked there, George, was about what happens with the hotels that are empty, et cetera, et cetera. What the government of Bahrain did was give a holiday for 3 months and say, right, nobody pays electricity bills, including the district cooling companies. Okay. So we suddenly had a transparency in the tariffs because we suddenly had the electricity costs taken out, and so everybody was shocked actually about how much money they were paying in their bill because of district cooling without electricity. Now, actually, that's the first time we've had this level of transparency in the market, actually.
Oh, nice.
And it was by default completely. So we're proposing, and I think it should be looked on as a model, a regulatory regime with an independent regulator that looks at tariffs, looks at transactions, looks at the buying and selling. If we want this industry to be, as we always say, a member of the infrastructure family, i.e. Sewage, drainage, electricity, water, and district cooling, just a normal member of the family, it has to be regulated. And what we're seeing here is an exploitation of the lack of regulation by government in ending up with this type of monopolistic type of consolidation. I'm really afraid of it.
We were not fortunate in Dubai. We only reduced 10% of the electricity bill, and the district cooling utility decreased 10% of their energy bill. So how that affected the energy prices of district cooling per ton hour in Bahrain when you remove the electricity portion? How much it was and how much it became?
Roughly around 50%.
50%?
Yes.
Although, I mean, electricity should be 80% probably, because most of Bahrain is seawater cooled or, Yani it's all depending on electricity big time.
Yes, about 50% was the tariff went down by 50%.
There's a question for Dominic from one of the attendees, and he's just chosen to be anonymous. And the question is, does Dominic have an indication of the costs to the government of adopting the cooling network? How long is a cooling network in Bahrain?
You mean how long is it existing in Bahrain, or how long is the networks?
It just says, how long is a cooling network in Bahrain? So obviously they're talking in terms of number of kilometers of the reticulation network.
I can give you in tonnage. I mean, we have a unique situation where we have in the street, in the urban area, 22,000 tons from Tabrid in one of our plants, and about, I think, 40,000 tons in Veolia. So we have a network in the public street as opposed to in a fixed master plan. In the fixed master plan in Bahrain Bay, we have a full network run by Veolia, and we have a number of plants run by the smaller plants, modular plants. For example, the US Army Navy base is district cooled. We have a Wali, which is district cooled, which is a small town. We have a major plant, 35,000, sorry, about 20,000 tons, but with 6,000 tons of thermal storage that has actually not been used yet. It's in mothballs, waiting for the recession to end. But I can give you details. I can give you more details on the actual specification of these networks. But I think the unusual thing is we've taken the approach that we would like to see district cooling in the street, capable of being connected to any development. And with that in mind, we have passed a planning law that any building permit where district cooling is existing must connect to the district cooling network. It can only not connect by making a case, a financial case against connection. And that is exposing the type of mathematics of alternative cooling systems against the district cooling offer in terms of charges.
Okay. My next question is for you, Bill, regarding repair and protection of cooling tower and related infrastructure and environmental concern of blowdown water. Is there a non-chemical treatment or possible or zero emission from blowdown?
So,
yes, sir.
I mean, first of all, good afternoon. Thanks, George, for the great question. Unfortunately, the question you've asked me doesn't actually fall into my expertise. Really, is in assess.
We are not hearing you clearly, Bill. Are you hearing him? We're not hearing you clearly. There is probably a connection problem. Even your image is freezing.
Okay, can you hear me now?
Yes, better.
Is that better?
Mm-hmm. Yeah.
Yes. Okay, go ahead, Bill.
Okay. So hopefully you can hear me now. Yeah. Okay. Great. Thanks for the great question. But within my and protection of concrete cooling,
Shall you fix that? Let me pass.
And cooling tips, or if you want to redirect your.
Bill, kindly fix your connection. I'll ask another question to Mr. Shekhar Reddy. Maybe by that time you fix your connection. The most difficult ones are for you, Mr. Reddy. Role of government in easing the situation. What measures are being considered to ensure all stakeholders, consultants, contractors, manufacturers, and suppliers, to name four, be able to sustain their business activity and enjoy positive cash flow? Right now, I mean, they took initiative, but they have very little impact on our industry.
We're talking, okay. We're talking of district cooling as well as in general as well. I think the cash flow has to improve in terms of there's a lot of money locked up in the market, and it's a chain process. You talk of from top to bottom, right from the client downwards. And of course, the sufferer is definitely the MEP contractor in particular. And of course, with due respect to all the design team and others who are the team overall, if you see. So there has been, okay, the government definitely, they took a lot of proactive measures, but how to make this, I think the word correctly used by Sagar is sustainable. You know, basically we see that still there's a huge gap between the thought process and the actions. And definitely it is biting the very effect of the product that is being served, and also in terms of the deliverables. Just to put it in a nutshell, I think the government, it's time that just like what they've done as a DIVA in terms of, I'm talking about the district cooling plants, it's time that they have a good meeting with the key operators of the plant, rather the developers of the plant, like the Tabreed, Empower already, okay, it's part of the government. They need to bring these people together and also the end user, and then have some sort of a forum to see how this particular, what the overall the concept of DCP, district cooling, is well understood and delivered. One thing, George, is that we need to think 90s. Now I think we're going back to 90s in terms of the thought process. It is very similar that think 21st century in terms of the technologies, but we have to think 90s, where the government did step in when there were issues. Of course, that was my starting of my career in Gulf, 1990, just after the Gulf War. And of course, Iran-Iraq war. There was a huge gap in terms of the funding and other issues. So government did step in. Around 4 to 5 years, the government supported the companies. And of course, that time, definitely the working system was totally different. But now that there's so much of a private-public equity there, so I think the concerned parties must be put together, and we need to have some sort of a resolution in terms, purely in terms of, let me use the word cash flow.
I mean, the government took measures here allowing unpaid leave, unpaid temporary reduction of salaries. What did you have to do, I mean, to reduce your operating costs?
I've become independent. I'm on my own now. So I mean, basically, yes, to reduce the cost, definitely we need to mitigate right from the human resources, which is a constant cost. And in terms of the liabilities, in terms of trying to clear out your backlog as much as possible within the available, available resources. And most importantly, strike some sort of a balance with the funding elements like the banks. But all said and done, especially it's not helping the contractors world. We do appreciate the hospitality side, they're really affected, the travel and tourism, very much affected. But I can tell you one thing is, there are a lot of medium and small scale units which have been supporting this industry. And as such, the mega plants of setting up these mega plants, operating these plants, all of them will be vanishing in the next 6 months, guaranteed. It is going to be a huge, huge setback in terms of the expert drainage. What do you call this? Lot of people are going to relocate. It's going to be a huge challenge in this perspective. So in terms of the government, basically what's happening is we are seeing only paper statements or in terms of their good thought in terms of how to revive things. But there's no concentrated effort in terms of calling, like construction is one of the major industry in this part of the world. So construction industry experts must be called. Together we can, in fact, it can be worked out. It's not that it can't be, it can be worked out. And there must be a hand-in-hand approach in terms of waiting out at least for the next 2 years, if not more.
Don't you think we have overbuilt and the construction industry need really to shrink and readjust itself to suit the market? Don't you think our current industry is way bigger than the market need?
I think, George, if you look at a futuristic way, I think we are in the right path. Yes, I do appreciate in the current situation, there's a oversupply, but it's very similar to if you have seen the automobiles. In 90s, you used to book the car and then get the car after 3-4 years. Now you walk in and pick what you want. And in terms of the stability, in terms of the connectivity, in terms of the overall, the what do you call this, in terms of continuity, you see that UAE is one of the forefront in terms of in the whole world, I can say. I come from India, I can see what's happening there. I see there's a huge, huge, of course, there will be a shift in construction. Maybe we'll be moving away from residential, commercial to industrialization, pharmaceuticals, possibly health services. That side could improve. And also, as what Dominic was telling, it's time that we as a GCC countries put hands together and have some sort of a common understanding in terms of how to, what do you call this, keep the things going. Let's accept that the whole world is going through a lot of turbulence now. And for sure, I'm pretty optimistic that UAE will come out, especially because it is going to be a safe haven in the future. So for sure, people are going to relocate. And when they come, just think there's no issues for any, like education, accommodations.
What my prediction, when I'm talking to many experts, they are saying that we're going to see less and less employed people in Dubai and more people who take Dubai as a second home.
Exactly, I agree with you.
Infrastructure that exists in the city. So we're going to see Dubai growing like London, like Paris, where people love to buy a second home and have them travel here. Maybe that could save the real estate industry here.
Again, coming to that, George, it is time. That is where we need to show that there is a system and there are, everything is, like there's nothing wrong in telling I'm going to charge you 2 dirhams, but there must be, that thing must be maintained. If there is a shift in that approach, then there is a problem. That's what they need. That's where they need to be in terms of, see, no question, okay, like I've been here for 30 years, okay, and I love every minute of it. I'm sure most of the people here. So yes, we are going through a difficult phase. And of course, we, again, George, we as experts have to come forward and say, this is the right way to go. Whether other guy listens or not is up. We need to put in what is right for this place. And I'm sure.
Mr. Reddy, you are also like sitting in London. I'm working on a couple of apartments, each worth £5 million each. Okay. And they are not allowed to put a condensing unit outside. There is protection on that real estate everywhere in London, where now we are seeing specialized companies trying to provide kind of water-cooled DX unit or difficult system in London. In that aspect, I mean, imagine you buy a £5 million apartment and you cannot air condition it in London with this heat. I mean, this is a more serious problem than really paying a fee. And these people don't mind paying a fortune to add AC, but the means to add an AC to such an apartment is close to impossible in London. Yeah,
And imagine,
there
imagine
are
the
other restrictions, and this is one of the best sought cities of the world, and you can see the restrictions that are there. Dubai, from that side, yes, has some transparency issues, but the flexibility and agility of the city is, we have less regulation than advanced cities that really restrict your options.
Agreed. And in fact, this is a very critical period. And I think it's a good thing that the Expo 2020 has moved to 21. There's time for them to put a framework so that when, I'm sure we'll have a number of visitors starting February, March of 2021. So by the time the Expo starts and then it picks up and then possibly by 2022, I'm very much confident or comfortable that this place is going to show the way to the world. Let's accept of it.
We're gonna see strong recovery mid-2021 and moving forward.
But
Bill, are you ready to come back to you? Bill? Hi, Bill. Can you unmute your...
Unmute. You need to unmute, yeah.
Bill is not hearing us. Once he's ready, we'll try to get him. Sagar, from your side, I mean, what measure did you have to do to survive this crisis? Did you have to reduce salaries, cut employment? What measures you had to do in your company?
See, George, we are in the field where the projects is a key. The moment we have the projects moving and taking it further, we can generate the cash flow. Yes, cash flow itself is the issue. But as we are part of the industry, we have also fine-tuned ourselves. Fortunately, we not reduced to a large extent, but yes, we have corrected ourselves in the whole scenario. While talking on the subject, I also would like to second what Mr. Reddy was saying. Is from here, the government actions will impart the confidence in the investors, because from India particularly, government has been quite vocal that they will expand their the expansion projects or the development projects to 2 to 3 folds. So once the government shows intent to develop certain thing, the investors will have the backing towards it. We're talking about here, yes, we are saturated, but then government should show confidence for the investors to come and to park the money over here or to invest over here.
Fine.
On the issue, when we are talking about district cooling as a subject, we are mentioning that how it can be have a common platform where everybody can use the network of it. Few years back, if you look solar, they were not allowing anything to sell on the grid. But Dubai and now other agencies are allowing to connect on grid, and that is becoming more sustainable, or you can say renewable energy is coming into the picture. In Europe, a few agencies, they have allowed online heating or the on-grid heating. If we can think of something of that sort for district cooling networks, where instead of having huge central plants, a common network, that can be a feasible solution and sustainable solution.
Let's keep our voice. Let's hope in one day it will happen. I've been calling for that for 10 years, but I think development happen when they are ready. Bill, are you back with us?
Yeah, I'm back with you. Hopefully you can hear me now.
Now we can hear you. Yes.
Okay, good. I had to call in through my phone, so sorry about that for the technical glitch. Good afternoon, everyone. Thanks, George, for the question. Unfortunately, I think the question you asked me is not really related to my area of expertise. So I think your question was related to some sustainable approach to maybe some chemical water treatment.
No. First, I mean, I think your expertise is repairing cooling tower basin, repairing of concrete. Is that
correct? Yes, yeah, exactly. So I work for a company called
Structured. We see a lot of older district cooling plant where this cooling tower basin is deteriorating, and we see structural issues with the basins.
Absolutely, yeah. So I was actually at a cooling tower yesterday, big facility in Dubai Festival City. We're currently repairing a project. We're repairing 2 cooling towers just behind JLT. So, the story behind these is that I guess a lot of the older structures, so old in Dubai means maybe 10, 12 years old. A lot of them are really suffering from durability related problems. So, that's related to corrosion. The concrete's maybe not suitably protected. Obviously, the chemicals that they add to the water, or that are added to the water, can cause additional chemical degradation. What we often see is that a lot of these older structures are not necessarily being maintained in the way that they should be. So whether that's due to budget constraints. The subject that I really wanted to talk about today, and what we talk a lot about to developers and owners and operators, is really how to ensure that you get best value for your repair. So, we at the moment, every single dirham which is spent investing into a structure is important, right? So owners, they deserve a right to make sure that the money that's being invested in the repairs, they're getting the best value on. So what we see a lot is, especially Dubai or UAE market at the moment, is very much price driven. So often, if a tender is put out to come and repair my cooling tower, then the owner will get five bids. They go to the last page, they look at the price, and they award the contract based on price. So unfortunately, what we've seen many times is that when owners buy using this procurement method purely based on price and not doing a commercial and technical evaluation, so you can buy on value, is that they often have early or premature failure of repairs. So we work on projects where the owners may have 2 years ago spent $1 million or 2 million dirham repairing their structures.
I also opened your US website, and so even here or there, you deal with strengthening GRP pipes in the ground, because we have a lot of GRP networks that are failing in our industry, where we have wall hair cracks or settlement at the manhole causing them to crack. Does your company have solution for piping network strengthening?
Yeah, we do. So we have a whole team which is dedicated to repair and strengthening of pipes, GRP pipes, or even concrete pipes. So generally, in very simple terms, the technology involves actually using carbon fiber. So we actually go inside the pipes, and they would use carbon fiber to actually, almost install a pipe within a pipe. So yeah, we have a full team which is dedicated to pipe rehabilitation.
You send a poor man inside the pipe, or you send a robot?
No, normally men go inside. So in the US, a lot of the pipes that they're repairing are big. They're large. They're large diameter pipes. But
they have to worry oxygen probably.
Yeah, exactly. It's extremely complex. But more for the local structures, we're more a lot of the cooling towers, because they have generally there's a lot of salt in the environment here. The cooling towers, obviously there's a lot of moisture around, so it's a perfect, if you like, concoction to have durability and corrosion related problems. And really what I think is important for owners and operators of cooling towers is to make sure that they engage the correct professionals. So often we see that owners want to get from they have a problem in their cooling tower. Maybe they have some delamination or spalling or structural damage of their basin, and they want to go straight to.
How do you repair these basins normally? I mean, do you do shot concretes there? What do you do? Do you do injection? Do you do?
So a whole mixture, but the repair process really contains 3 parts. So the first part is investigation. So generally, you don't have one single problem with your structures. It's normally a whole mixture of structures. So it's important to have the first stage of investigation. So this would normally involve engaging an experienced professional consultant who would come in, and he would assess the root cause of what the problem is, determine the extent of the problem, and then you get to the next stage, which would be the engineering. So engineering there's lots of ways to skin a cat. So, it's really important to make sure you look at all the different options and enable owners to get best value. And then you have the implementation. So for implementation on basins, typically we are replacing linings. So a lot of the cooling towers, they have GRP linings, for example, on the basin. So GRP is a fairly old technology. So there's much better technologies which are available now, which provide,
Which
more long
like
term.
what do you use instead of GRP lining?
Like a polyurea, for example, a spray pride 2 millimeter thick polyurea lining, which is it provides provides better protection, has good protection against abrasion, and it's not rigid like GRP. Of course, all membrane or protection systems are only as good as the substrate which they're being installed onto. So coatings and membranes is one part. Another part is often the steel has actually started to rust. So when it rusts, it expands and causes the concrete to pop off. So then you need to do an actual, a concrete repair, which involves, breaking out all of the damaged concrete, cleaning the rust off the steel, installing additional steel, and casting it back. So I think you mentioned before about shotcrete. So there's different types of concrete applications. Could be shotcrete, could be through form and fork, could be through form and pump.
Sure.
And then there's,
Let's
other.
check with Surinder. Do we have a lot of questions? Because we have still 20 minutes.
We have some questions, George. I mean, there are two questions that sort of are similar in nature. One is by Saeed Ahmed, and he wants to know, with this present condition of COVID and its uncertain effect on future, is it advisable at this point to venture into district cooling? So that's one question. The other question is by Michael S. And he asks, is district cooling more efficient and more economical than standard building chiller cooling on short and long-term basis? What is the impact on end user bill as we are expecting difficult times ahead?
PB Nike, are you ready to take this question? Did you hear them?
Yeah, I heard. As I said, because of the slab tariff, Dubai is affected in an advertent way compared to Bahrain or Qatar, where there is one tariff. Because of the slab tariff, we end up paying 44 fils per kilowatt hour, whereas somewhere else, it is not affected that way. You see, if you go for a DX system in a small flat apartment, your tariff starts with 23 fils per kilowatt hour, and then it increases to 28, 35, etc. So the benefit what district cooling utility provider gets by, or what you call, he should apply for a concession from DIWA, because DIWA is benefited in a long run with reduced carbon footprint and things like that. Finally, the infrastructure cost is reduced to the government, but the government, I don't think, is passing it on to the utility provider. This is why in Dubai, people are a bit hesitant to go for district cooling compared to even Abu Dhabi, Bahrain, and Qatar. The operation cost is quite high, almost 65 fils per ton hour. Whereas when I did standalone water-cooled plant design in the same Sheikh Zayed Road, it was costing me less than 50 fils. So why it is costing so much? I don't know. In fact, the utility provider, when he has got multiple buildings connected, he will have a diversity as low as 70%, as against a standalone building diversity of 85%. So there is a benefit, but it is hidden. It is not passed on to the end users. This is the reason.
PB, also on another subject, on blow down from cooling tower.
Yeah, you can use everything for irrigation, because even if you consider 5 or 6 cycle of concentration, the chloride level is 300 ppm or so, which is fine for the plants. No need to treat even if it is going for irrigation. But if you are trying to reuse, then you can put an RO plant and then try to reuse, but then it is expensive. But I suggest the blow down should be let it through irrigation.
Okay, good suggestion.
Yeah.
Surrender,
But
any more question?
There are two questions.
Sorry, one other point. See, this, if you see, these are essential services. Let's call even chilled water is an essential service because it's providing a definitive requirement for the comfort of the local population. Now, being essential service, I don't understand why certain of the operators are, in fact, if you see in papers, they're putting even the profit. Why the profit? It has to come back to the end user. It has to come back to that guy must get the benefit for utilizing the particular facility. And also other thing is alternative energy. In fact, when I was looking at the design of this Maidan plant, which of course has not yet come up, one of the best solutions has come in using gas as one of the options than the power. And gas is in abundance. Again, there were a lot of, though Maidan themselves has intervened as a client, unfortunately it didn't go through because there were so many of unnecessary, I think unwanted restrictions. This is where the government has to see, and this is where even I'm sure, especially the 21st century people who are coming, they will look for quality life and quality service at a good price. So this is what the guys who are going to, so this place, if they want to attract the people, there must be, as I think a lot of people use the word, transparency must be there in terms of for everything what is happening around.
Surrender, what are the last two questions?
Sure, I'm not sure if this relates to what Shekhar just spoke about, but the question, this one's by Jay Kumar Cheladurai, and he says this, and I think he's referring to COVID, this is an unexpected situation that we need to come across or overcome. Can we take this as the saturation limit for this industry due to migration of people due to COVID-19? If the occupancy remains less, how can we be optimistic in terms of cost? He says, I mean, how we can make cost optimistic. I think it's, he really means to say, how can we...
With reduced population and we have the same system connected, there'll be less utilization of the district cooling industry. And they think, is it really saturated? The solution me and Dominic, we share, I think, is by having common network, because now at best in Dubai, I mean, the district cooling share is 20%. What we have in existing chiller can cover 60% in Dubai if we have a common network. So the solution to utilize this capacity is through common network. The point of saturation, no, we think that district cooling is still, it is in not infancy, I would say in development stage, early development stage. We still have some room before it matures. And you know, countries like Iceland has 100% coverage in district heating. Country like Denmark has 60% coverage in district heating. So we have yet, I mean, I think with the concentration of Dubai, 60 to 70% of Dubai can be covered by district cooling. So we have yet room to mature. To mitigate the risk of reduced population, one area is the common network where we connect additional building to the same district cooling plant and make better utilization of it.
George, just to add on that, when you talk about Europe, these district heating plants are basically cogeneration or CHP, where they're using the heat, which is from the industry, etc., for heating the spaces. And similarly, if you talk about the Helsinki, etc., which they have used completely district cooling network, the lot of things they have used is the seawater. So we are not spending the energy for cooling the water. Now these are two different aspects. Here we have in a very atmospheric, which is very adverse, where we are spending huge amount of energy to cool the chilled water. Unlike the European countries where we have either cold water available or we are using the waste heat from the industry to heat the things. So it cannot be actually compared. That's what I feel. What do you take on that? And because of that, the cost is on a higher side.
Let's look at Denmark, where they are going 100% renewable. And there they are, okay, part of it is
Biogas.
Biodiversity.
I think they use wood pellets. They call it as biofuel or renewable. They have heat recovery from, okay, waste incinerator, an old system, but they rather not do it now in the future. They have some wastage coming from data center and industry that feed the system. Also, that's useful. And now they are pushing for some deep geothermal energy and heat pump powered by wind turbines. Wind turbine contribute to 60% of the energy mix in Denmark, and it's the main driver of their support. Here, we can have the solar energy driving our district cooling plant. And this is what is still lacking, the integration between the upcoming solar energy that's growing at exponential rate and our industry, which either is not being let in to serve or to integrate by the utility and by the governments, or they are not taking enough initiative themselves to be part of that this industry. This is the main difference. Now, when we talk about natural gas, I have a colleague who is now based in Amsterdam. We were talking last week. All last year, Amsterdam was deconnecting natural gas from housing for heating and cooking. And they want everybody to go for electricity, heat pump, district energy powered by renewables. They even look at natural gas as a polluter. Okay, it's less polluter than by far than coal, but still they look at it as a polluter. And I never heard of a country deconnecting natural gas from housing, and they took this initiative. They even frozen the development of any new data center for a whole 1 year because of lack of power and transition. That's what's happening in these advanced countries. Their thinking and their integration of policies is way ahead of us. What we are lacking here is an integrated policy that capture all these elements of energy and put them to the use of society and of environment. That's probably the key thing. Dominic can comment on that as well.
Yeah, in fact, there's one more question I think that's related to Dominic. Can I just read that out? It's the person who's written it has chosen to be anonymous. And he says, on the question of a common network, will extra cost associated in pumping still allow district cooling to be cost effective? In low density, and within brackets he says long network areas, district cooling is generally not feasible.
Look, I think we need to really focus here on what we're talking about. We're talking about cities, we're talking about high densities. We're not talking, although we have a residential area, one residential area that's district cooled since 1948. And I'll give you some facts and figures on the details of our networks. We have looked at two companies, Veolia and Tabreed. We have asked them to look at the technical issues with interconnection. They've come up now with solutions to interconnect two independent networks. The last part of the jigsaw puzzle to actually make it happen in a sustainable and, for us, a psychological, helpful way, because if one fails, the other picks up. So in order to do that, we are left with them having a commercial discussion. This is behind the curtain on the company structure of their finance, et cetera, But physically, we can connect, and we want them to connect, and we want to make regulations to push connection. But can I just change this discussion slightly for something I want to say that's very important, I feel, and that is COVID has taken us by surprise. When I saw a documentary about a hospital in Italy, I saw a doctor being interviewed. What was he doing while he was being interviewed? He was opening the windows of all the corridors in the hospital. And when he was asked, why are you doing this? He said, I need ventilation. Now, the science has not come up yet and has not been definitive. I see many of you are talking from your homes. I'm from my office. When we go back to our offices, we live in buildings where windows don't open. There is no ventilation. The humidity is controlled. We know the virus lives in low humidity. We know that it can circulate through AC systems. What is the industry going to respond to the next part of the control of this virus, which now that we move away from social distancing and all of these things, in living safely in our buildings that are sealed with 80% of our air circulated with low ventilation? We think we will have to change our energy regulations to allow a decrease in energy efficiency as we increase ventilation in buildings and we increase air circulation and we control humidity. I think this is the big technical, the big medical, and the big facilities management challenge, and eventually it will result in a major change in how we design our buildings. Ventilation, air circulation, humidity. These are going to be the new agenda. It may break next week, it may be a month, but the science is already building up that the way we cool our buildings, the way we build our buildings, the way we seal our buildings is actually causing problems with this virus.
Especially hospitals.
Hospitals have to have their ventilation and their air circulation and exhaust, and that is going to be an enormous change to the energy targets for efficiency. We're going to have to live with less efficiency, pay more as we achieve greater air exchange, ventilation, and we look at this humidity problem. Higher humidity, more circulation, less circulation and more ventilation. That's the key to dealing with this virus.
Surrender, if you don't mind, I would like to conclude this plenary discussion now.
We have 6 more minutes left, George, and we have quite a few questions coming in. Could I just shoot some questions now?
Yes, go ahead.
Yeah. Okay, these are related to cooling towers and water in general. This question is from Mohammed Mumani, and he says, are PPR pipes, can be used for cooling towers? He says, can PPR pipes be used for cooling towers exposed to sun? That's one question. And then, if you just bear with me, I'm just scrolling down. Here's one more question. Would district cooling service providers be open to non-chemical water treatment systems for control of lime scale and subsequent corrosion of cooling towers? Has any such technology been tried in this market previously?
We have 2 or 3 plants in the area that are using non-chemical treatment. Now, PPR, I've seen it use it outdoor for water, but limited in diameter. So cooling tower require large diameters pipe. I don't know if PPR exists for the 20-inch. I don't think it does, or bigger.
No,
so
no.
It's limited to 12-inch probably as PPR.
That's,
and there's one more question, sorry, if I may, because we're running out of time. This is from Muhammad Mumani again, and he says, regarding irrigation from blowdown, our irrigation department is asking for TDS less than 900 ppm. Is there any code we can enforce them to use, is there any code we can force them to use 2500 ppm TDS blowdown water?
True, it is a difficult point in the regulation here, But I think most people are managing it when we are submitting. They are not being very strict on the 900. Is he relating that to Abu Dhabi regulation?
He hasn't specified, no.
Okay.
But there is a question related to Abu Dhabi and Dubai, in fact, and says, does a central gas network exist in Dubai or Abu Dhabi? Perhaps that could be why gas chillers are not recommended.
Sorry, gas?
That could be why gas chillers are not recommended.
We have natural gas possible to get it in Jebel Ali port area. Some people try to, and they were given a slightly high price. In Abu Dhabi, the network is limited in Musaffa and Zayed military city, and the pricing are escalating way beyond international pricing. I mean, ADNOC probably has reached 14 dirham, 15 dirham per million BTU. That's $4 or $5, while in the pipeline in US now it's under $2, the natural gas. While in Dubai, they are talking about $8.
My experience when I came to this Maidan plant, the pipeline, which was, okay, it's coming from, I understand one particular pipeline is coming from Oman for to our Jebel Ali plant. So, Enoch plant, sorry, Emirates gas plant. And we were to take a tap off from there, run the piping on the Emirates road, and then connect to the DCP plant, which is located next to the Dubai Align Road. That is, I'm talking in terms of the Dubai Mall. In fact, the ROI of that was so attractive. So that's where the management said, why don't we go for this? Unfortunately, the way the unit is priced in terms of the gas, for what they were being supplied and for what they're going to charge, that is not viable in terms of the ROI. And Surinder, just to answer your point about saturation of this plant, yes, there is certain.
I'm sorry. Just one sec, Prabhakar Naik. I think there's some disturbance coming from your side. Yes. Now it's perfect.
Okay. Gentlemen, I want to thank you all. I would like to conclude this panel to be on time. We are 3:40. I like to be ahead of it.
Yeah, George, in fact, there are some more questions. I think we will take them towards the end when we have the audience Q&A.
Okay. Okay.
Thank you, George. Thank you. Thank you, sir.
Thank you.
Thank you.
Thank you, our panelists. Please invite all your speakers now so we can go to the second presentation. Second presenter is Mr. Peter Thomson. He's a director of Building System Solution Group on Armstrong Fluid Technology. Peter is a director of Building Systems. He provides leadership to project engineering, product development, IP management, and business strategy. Prior to joining Armstrong in 2001, Peter's career spanned several industries, including energy conservation, power generation, and commercial construction. He holds a degree in physics and an MBA from Schulich School of Business. We welcome you, Peter. Please, if you are available, start your presentation.
Thank you, George. I think someone will activate my camera and you should be able to see me shortly. Can you hear me, George?
We can hear you. We don't see you. Maybe, okay. Okay, this is your screen, fine.
It is, yes. Can you see me?
No, we cannot see you. Maybe you are stopping your video. If you can...
because the host is stopping.
If you can see as a corner, a video camera with a slash, press on it, maybe it will...
Yes, I've tried that. It says that the administrator has turned my camera off.
Surinder is there that she can help.
Yes, I'm going to be checking on that. Just give me a few seconds.
But at least, Peter, we can see your screen, the first page. You can start your presentation until they work on your camera.
Thank you, George. Well, thank you everyone for attending this afternoon and taking time out of your busy day. I really enjoyed the panel discussion. A lot of the subjects that you brought up are not unique to your region. It's interesting when I travel around the world and the challenges that we have both economically in certain parts of the world and now with COVID-19. It's a very changing and very dynamic situation as we look to the built community. And what the new requirements are going to be, yet to be defined in my mind. I think there are going to be some changes as were just discussed, but also the expectations, the loading, the number of people who are going into these large office buildings or large shopping malls may be changing a little bit as new trends start.
We can see you now, Peter.
Around the world. That were already in place, and those infrastructures, oh great, and those infrastructures are continuing to build out to help service people more to live in their home and do less public space in their lifestyle. So a little bit of background on Armstrong. We are a designer, manufacturer, and servicer of heat transfer and fluid flow equipment, and we were incorporated in 1934. A little bit of background for the last 20 years, which is more relevant to the subject today, has to do with our method of demand-based control that we integrate into our products to make them smart with very intensive digitalization. And it's not unique to Armstrong, this approach. This approach has been used in the aerospace industry of digitalization. This has been used in the automotive industry. And it seems like the HVAC, the cooling industry and the heating industry tends to lag that a little bit. Even the power plants for power generation are not yet up to speed as to where the aerospace is with digitalization. So you can see on the right, this is a project from my hometown, Toronto, an N-Wave project, a couple of 600 kilowatt pumps taking some deep lake cooling water into a cooling plant. So the subject that I'll be presenting today is plant intelligence and the network effect, district cooling reimagined. And it has to do with the heavy digitalization of our operating facilities to understand them better. And that's going to help us as we go through this time with COVID-19 today, and also for what people are saying is coming for our buildings in the future and for our cooling facilities. So I'm going to do a little bit of a tech talk, and throughout that, I will ground it with some business talk, because it does have some very positive business implications, and that's important to remain viable and economic in these changing times. And what I'm going to present is helpful for the COVID-19 experience, but is also helpful outside of that realm also. So why might people be interested? What can digitalization do for us in our district cooling facilities? It can actually reduce the upfront cost during design and construction by 5 and 20%. And I'm going to explain how that works. It can improve the efficiency of the full network, up to 40 cents per square foot of living space. So of the service space, the building space, 40 cents per square foot per year. Quite a significant number. It can increase the market opportunity by 350%. And the way we do this is with the digital technology. The investment is smaller, the operating costs are lower, so smaller and medium-sized district cooling becomes more viable. And we're seeing a lot of small and medium-sized district cooling and district heating popping up all around the world. Also, it can help us with green or sustainable initiatives to bring a good ROI for those investments. So why should it be interesting from a business perspective? It provides us reduced capital, improves our OPEX, reduces the amount of infrastructure required, and improves our economics, so to speak. And it does this with transparency, a level of transparency that we can't get outside of the digital world. And we all know how well we're connected with our mobile devices and our smart TVs and everything that now has intelligence in our products. we should have that same level of intelligence, same level of self-awareness within the equipment, within our plants, so that we can be just as transparent on its condition, its operating efficiency, its need for service, and its capacity at these changing times. So what's different about it? Well, it all starts with this. It's a method of control. It's called feed-forward control, where we observe a load change, so a requirement, whether it's water flow or airflow or some requirement changes, maybe a valve opens in response to another controller. And there's a predetermined response for the process. It's a control map. It's you do this, I do that, and then the process controller changes and the process variable changes. So it's very unlike traditional control, which is a feedback control method. And with feedback control, you have a sensor picking up the output, in our case, typically temperature. And that signal gets feedback to a controller where it's compared to a set point. And then there's a adjustment signal sent out to a controlled device, maybe a valve or a fan speed. And then the sensor monitors the change of the output. The problem and challenge with this is it's somewhat unpredictable. We're not sure what the power draw is going to be. There's no way to create a digital twin from this. And it tends to hunt a lot. It tends to overshoot the set point and go under the set point. So we get these natural transients within the system. So with a digital solution, where we create a digital model of our entire building and our district cooling network, we're going to be able to have a much more predictable system, both at device levels, subsystem levels. So let's talk about an energy transfer station at a building, and also at the whole system level. And that's what I'm going to focus on in the next few slides. So, digital twin. This is a phrase that many of you have probably heard of. And it's basically a digital model that represents the actual performance characteristics of interest. In this case, I've shown a small pump, and it has a digital twin embedded inside of it. It knows from the factory what its performance print was, its equipment performance map, and it's able to observe changes over time. So we can adjust its behavior to compensate for external changes in the environment or internal changes within the device itself. So that digital twin isn't a static twin, it's an evolving twin. So over time, as the conditions change, we see how that equipment performance map for that digital twin has changed, and it opens the door for some machine learning applications to optimize at the device level and the system level. So if we had a family of these digital twin devices working in parallel, shown here as 3 pumps, we'd be able to know the performance of any combination of 1, 2, or 3 of these. And we'd be able to predict with high accuracy, if we were interested in energy efficiency for a given flow and head requirement, what the optimal combination of equipment would be to run and what speed to run it at. We can also take this concept to the next level, an energy transfer station, where we can create that same digital fingerprint or equipment performance model of the heat transfer surface area. So we're able to monitor the heat transfer coefficient for the whole device. We're able to observe the changes over time if one side starts to get contaminated. We're able to track the amount of energy to move the water through the devices by combining it with intelligent flow management systems. And we're able to create a digital fingerprint or performance map for that whole energy transfer station.
Peter, you still have 5 minutes, please.
Yeah. And we can take that up to the next level for an entire chiller plant in many more dimensions. And we are able to provide the best performance, be able to ensure that we get the savings of water, get savings of energy, and give great transparency. So what we have now is a system that can respond actively on its own without intervention from other operators with a hands-on approach. So these can largely be self-optimized without operator intervention. So these intelligent devices create an equipment performance map, and I've shown a very simple one here for a two-dimensional pump device where we have flow and head and power and speed. So there's a unique combination for each operating point. So if we know the power and speed, we would know the flow and head. This just gives you an idea of how those maps get created. And that's how we're enabled to know that if we add another parallel device, whether it would be more efficient to add it now or wait a little bit longer or remove it from the duty cycle. And this is taken all the way up to the chiller plant level, where we calculate these digital twin models on the edge with today's higher speed and higher capacity processors, and enables us to create those advanced maps and give a correlation between the actual performance and what was expected to know what the state of repair is. And when that state of repair changes in a plant, maybe the cooling towers get fouled, we're able to recalculate with a new digital twin what the optimized control map is for that new condition of equipment. And also send out a message to the operator that we need to clean the fill on cooling tower number 3. One of the biggest challenges that we've seen with any plant is that drift is inevitable. Things happen that the operator cannot be sensitive to without the accuracy and capabilities of a digital twin. We're able to see minute trends and changes in performance ratios. And shown on this blue line would be a traditional plant's operation over time. And it wouldn't be until performance has drifted this far before it's noticed on the output readings for the week in terms of maybe kilowatts per ton. Whereas with a self-optimizing system that learns, it's able to notify the operator, specifically pinpoint them to the right area, and change its course of direction, just like SatNav does when you're in traffic. ASHRAE has recognized that high performance systems tend to lose about 20% to 25% of their performance due to this drift. The digital twins allow us to move along this green line. And what we've seen is digital twins also help improve beyond what the predicted performance was originally, because they're learning over time new ways of operating the plant rather than the traditional approach that we've used for control. And this leads to an additional 8% of savings in terms of energy. And we also see within the industry cognitive intelligence at the cloud level, where large populations of data from different chiller plants are being brought up to the cloud. And from that universe of chiller plant operations, we can learn how to accelerate the improvement in the plant performance. Whether we're more sensitive to power or water consumption, those could be set as the optimized variables for the learning algorithm to minimize. This also helps us reduce the maintenance calls that are traditionally scheduled on a time basis. So it'll be able to give us transparency on performance, but also give notification for condition-based maintenance. So this transparency in the time of COVID is helpful for us because it's going to minimize the number of hours that our maintenance people need to spend on site. And when they're there, they can do the things that will have the largest impact. In terms of changing the cost of construction, traditionally, we've always thought of laying our plants out with the same size and capacity of equipment as shown on the left, maybe 6 chillers at 20%, giving 120% capacity. Same with the pumps and cooling towers. Now with this method of control, we're able to operate any combination of size of equipment with an all variable speed solution, and we can reduce our capital investment. And this is what's making some of the smaller and medium-sized district cooling plants more viable economically, because we're reducing the original investment, somewhere around $3 per square foot served. We're improving the OpEx by about 40 to 45 cents per square foot, and lowering maintenance costs, the overall maintenance cost for these systems being reduced by about 5 cents per square foot served. So the new technology also extends to district cooling plants, whether you're running with a temperature contract to supply temperature to the building, or if you're on the building side and you have a temperature and load contract, we can create digital models, and they exist today, to optimize both scenarios. And you're able to pinpoint within the building if there's an air side complication. So by creating this networked model for a district cooling solution, we're able to observe if there are any clients on the cooling loop that have a problem with their air side. And if you can adjust your contract, perhaps you provide them a penalty as a new business model where you give an incentive to a well-performing plant building. So in times of COVID-19, to wrap up, this new digital technology and networked capability helps to bring transparency to the owners and operator of the facility, makes it more viable with economics, with those learning algorithms to get better performance, gives a good condition of capacity without those regular scheduled maintenance visits, provides diagnostics for condition-based maintenance to only dispatch people when you really need to, which is challenging in these times. And in a period of lower customer demand, and this is worldwide, which usually means less revenue, the higher efficiency will keep the district cooling service provider more financially solvent. So these are benefits for the COVID-19, but there are also benefits that are important to any business person, no matter what we're going through worldwide. So that was a very quick presentation, 15 minutes on how digitalization is helping to reduce the infrastructure, capital, OpEx, and increase the capacity with very good transparency of your operations through digitalization.
Thank you, Peter. You are done?
Yes.
Thank you very much.
Thank you. I think I got it a few minutes over, but
yes, no worries. Our second speaker is Dr. Ali Nouri. He's CEO of Smart Energy, accumulated more than 30 years experience in energy sector, covering engineering, project execution, and development. And are you ready, Dr. Ali, to come up?
Yes, yes, I am.
Yeah. Go ahead.
Thank you, Mr. Chairman. Good afternoon, everybody, and thanks to CPI Industry for the invitation to participate in this webinar. So sorry, I'm just going back. I'm starting with the results, which is probably too quick. So my presentation today is about energy efficiency in district cooling plants. Smart Energy, as was mentioned, is a company that deals with energy efficiency in the industry sector in the MENA region, and I will be sharing this presentation with my colleague Guillaume, who is already on connected. So since the beginning of this webinar, we heard about how district cooling is going through challenging times, and as compared to the traditional AC, I would say. So here, just some numbers. In the Middle East, we have about 85 million refrigeration tons of installed air cooling capacity by traditional means, and about 7.5 million RTs of district cooling. So it represents a little bit less than 10%, and probably in cities like Dubai, we can reach barely 20%. So this is a kind of AC-DC paradox where, while the district cooling is more efficient, probably 2 times more efficient than the traditional air conditioning, its penetration and its contribution to the overall cooling in the Middle East is still quite low. So we talked also, and many panelists talked about the effect of COVID, but the general tendency is that the district cooling plants are in kind of overcapacity, and more efficient operations and more efficient redesign of the district cooling would certainly lead to more efficient district cooling plants, and would, of course, help in the penetration and the spread and the benefits of district cooling to both operators and users. So my presentation, or our presentation, is on the ways to improve the energy efficiency of district cooling plants, and we will go through some case studies and examples, live example, real life examples in which what we are promoting here as a way to reduce to improve the energy efficiency are put into practice. So basically, we have 3 levers. Consecutive levers. The first one is what we would call automation, digitalization, and a way of automatically having the district cooling work all the time at optimum set points, which is making the district cooling adapt to the load, to the varying load across the year, across the day, with COVID, certainly. So we need district cooling to be much more versatile and adaptable to the changing load, and also to the changing weather conditions. And increase or generalize the automation of the district cooling so that it adapts automatically without the intervention of the operators. And this is what we have implemented in a few district cooling plants in the region, and we would be very happy to share with you the results of that. The second lever, of course, is to have the district cooling sometimes generalizing the speed drives. Not all the district cooling have VFDs on most of the equipment. Very few have VFDs on the compressors. Some have that on the chilled water distribution network, but not all of them have that for instance, on the cooling towers or condenser water pumps. And we think that the combination of the optimum parameters, optimum calculation on the fly, live calculation of optimum parameters, and the retrofit, we can really increase the efficiency by a very important number that we will share with you in a minute. And of course, while number 1 and 2 will help also addressing the Delta T syndrome, some aspects are to be tracked down into the users. So I leave the floor to my colleague Guillaume, who will be presenting optimum coefficient of performance and its application to some case studies.
Thank you, Ali, and good afternoon, everyone. We're going to be talking about this solution OCP, optimum coefficient of performance. OCP is an optimizer, meaning that it communicates with the plant's PLC. It doesn't substitute the plant's PLC. It's been specifically developed to district cooling plants with MENA region district cooling plants conditions in mind. The main component is dealing with the heat rejection apparatus, where we're trying to find a set point that will reduce the plant's consumption, going a little bit further than the usual floating head pressure that we see in relatively modern plants. The second module that is incorporated in this solution is an optimizer of the distribution system, the chilled water distribution system. We've developed a novel way to distribute chilled water on large districts by finding the hydraulic minimum for the distribution to ensure that all the customers are just supplied. And finally, the module we call OCP Drive is a plant sequencer. It controls the plant as would the ideal plant operator, never making any mistake and always finding the right combination of equipment to minimize the plant consumption while ensuring quality of supply to all the customers. So this is the tool, and we're going to go through 2 case studies. The first case study has been done on a plant that we've talked a lot today, which is the plant where I started my career, actually, in Veolia in Bahrain. This is a relatively modern plant. It's less than 10 years old. It's got a series counterflow YK chillers arrangement, and it's got just a variable primary pumping. There's no TES. There's no secondary pumps. The great thing is that it's got VFDs on both condenser and chilled water pumps, but not on the compressors. What's quite important to mention here is that the site's got a fairly mature operations team with a lot of efforts that I've already put into looking for ways to increase efficiency. We've deployed an IPMVP type method to validate the savings generated by the solution, which is where the model you can see on the right of the screen. And we've implemented 2 of the modules that we've talked about before, the optimization of the heat rejection side and the dynamic chilled water DP set point reset. We didn't look into plant sequencing because since this is a variable primary, only the sequencing didn't have much impact. So the results are very good. We're very satisfied with the result. We've achieved 8.4% savings based on the overall plant consumption. This was a proof of concept. This was our first reference in the Gulf, so we decided to go through an on-off validation. The plant was on for the OCP solution was on for 3 months between the 1st of September until the 1st of December, which was interesting in terms of representation because it covers a little bit of summer and the mid-season, which is usually where it's difficult to find the optimum set point due to significant changes in the weather occurring. And what you can see on the green curve is the cumulative savings over the period, and you can see that as soon as the solution switched off, the savings starts. I mean, it's leading to overconsumption essentially. And so the system went back on in April, and the savings you can see are increasing afterwards. We are currently working on. You went too fast. We're currently working on the last development, which is the dynamic chilled water temperature set point reset. Considering this is a fixed. I mean, this is a variable primary plant. There is quite high limitations on how low the primary flow can reduce, and having a chilled water temperature set point reset is an improvement that we're testing right now. So the second case study is a Tabrid plant, which I believe is fairly representative of the average district cooling plant in the region. This is it's fairly new. It's less than 5 years old. It's about 30,000 RT, and it's got a primary variable secondary system, fully mutualized with TS tank and VFDs on the chilled water pumps and the cooling towers, but not on the condenser pumps and on the chiller compressors. We've taken the same approach, deploying an IPMVP method, and we've gone a little bit further than on the Veolia plant since we've deployed the cooling tower optimization, the dynamic chilled water DP set point reset, and in this case, the whole plant sequencing. You can move on to the next one, and the results are very satisfying as well. We've achieved 9% global savings on the consumption of the plant, similarly, by doing a systematic research of the hydraulic minimum. So this is what I was mentioning earlier, minimizing the secondary pump speed as much as possible, implementing TES tank management, and in the whole plan sequencing, something that I'd like to point, because I noticed that there was a questions with regards to smart solution and automation. While the system was on for a duration of 3 months, there was no operator intervention required. So the operators were supervising and ensuring that nothing was getting outside of what was contractually allowable. But the system managed to sequence and run the plant automatically for 3 months, while generating 9% savings compared to standard operating practices. And on this plant in particular, we're currently looking at.
Sorry, Guillaume, to interrupt. Can you conclude in 2 minutes, please?
Yeah. We're currently looking at an improvement, which would be to take into consideration weather prediction to optimize TES charging.
Thanks, Guillaume. So we also tried, through investment grade audits to perform retrofit of existing DCPs, implementing VFDs on CT fans and condenser water pumps, together with the implementation of OCP, and the results are even better than the 10%. We are exceeding the 15% energy savings. So to summarize, here are these three-step strategy: automation and optimum research and optimum calculation of the set points leads to basically 10% of energy savings. Retrofitting and adapting and rescaling the design to the actual needs would lead you to probably 15-20%, and addressing the low delta T would provide you with the optimum to be around 25 to 30% savings. Of course, all this depends on the DCP itself and the maturity of the operation team, but usually ends up with a return on investment of about 1 to 3 years, which is absolutely good. So with this, thank you very much. And I would like to thank our partners, Tabreed and Veolia, who has allowed us to share with you the results. Thank you.
Most welcome, and thank you for both of you. Our second presenter is Mr. Moan Abraham from Filio Project Management. Mr. Moan is Business Development and Marketing Consultant for Mammoth HVAC and Rosemax cooling towers for MEA region, and associated with Filio Project Management since March 2020. He has a degree in mechanical engineering and over 26 years. Please go ahead, Mark.
Hello, good afternoon. Thank you very much, George. So it will be a very fast presentation because I have about 17 slides. So just a quick introduction about the Mammoth Group and what are our key products, some key technologies I'll be focusing on, also some introduction on Rosemax and some key products that we have and some key technologies, and also a little bit about our distributor in UAE. So Mammoth is an American company established in 1935 and with operations globally, and they have also a setup in China, which they set up in 2002, and they manufacture energy saving products up to 1,800 ton. They have been supplying indoor climate products throughout the world, incorporating the best of energy efficiency, innovation, quality, and performance. In terms of the product range, the key products are the water-cooled centrifugal chillers up to 2,800 tons, the water-cooled screw chillers, the air-cooled screw chillers, rooftop package units, and the VRF systems, air handling units, and fan coil units. So we cover a full range of commercial HVAC from chillers down to the VRF systems. I'd like to just take a few slides on our centrifugal chiller. We have two models, which is a single compressor up to 1,400 tons and twin compressor between 1,500 to 2,800 tons. The main features, some of the main features of our chillers, I'm not going to go one by one, but you could see that. So some of the highlights is that we're using R134A, all the latest technologies in terms of the centrifugal chiller, also the 11 kilowatt, 11 kV power supply, we can also provide that. And the biggest advantage is that we can provide centrifugal chillers with a very short lead time of 60 to 75 days ex-factory China. So that's some of our features of our chillers. Also, a little bit going deep into the product itself, we are using a two-stage centrifugal compressor, semi-hermetic motor, and it is liquid refrigerant cool, low temperature running, and high efficiency. And also it's a low noise operation. In terms of the operational range, we are having a full capacity range in the two types, fixed frequency unit and inverter unit. And the capacity control can go as low as 5% to 100%. This is our operation range. In terms of our technology, we also use an economizer to enable to separate the vapor and liquid effectively in the economizer, and to enable it to enter the compressor for secondary compression. And also the oil contains refrigerant with evaporator, will be heated to vapor, and oil returns back to the compressor oil tank. The high temperature lube oil from compressor will enter economizer to be cooled down to proper oil temperature. This is injected into the parts of the compressor which needs to be lubricated. We also provide a lot of customized products. So VFD is one of our customization. We provide high evaporation temperature centrifugal chiller for industrial plant application, temperature, humidity independent control. We have various living chilled water temperature range, entering cooling water temperature range. We have a flooded unit customization, copper nickel heat exchanger customization. Also, we have a heat recovery unit, which can be effectively used for hot water or production process hot water, not only to achieve waste heat utilization, but also to reduce heat pollution generated by condensation and reduce the cooling tower operation cost. We have also high COP customization unit, high IPLV customization unit using dual IGV compressor, and other customization required by the customer. The other part I would like to highlight is the Rosemex cooling towers. So Rosemex is a company incorporated in Canada, is a manufacturer of high quality heat exchanger products used for heating, ventilation, and air conditioning. These products include cooling towers, fluid coolers, evaporative condensers, and other products that we have in our range. Rosemex is also an exporter of energy saving equipment globally for the HVAC industry, and we meet a lot of global standards and certifications. In terms of products which we have for the cooling towers, we have the open type, closed type, and evaporative condenser. Some of the key technologies that we use are the water spray distribution system, which utilizes self-balanced buffer tank to provide evenly pressurized uniform water distribution by gravity. Also, it consists of water inlet valve, water distribution pipes, pre-cooling fill, nozzles, which all make up to the water spray distribution system. The other one is the fill spray system, are designed for flame retarded PVC material to give the best thermal performance, taking into consideration ventilation, water quality, and maintenance. Fills maximizes the heat exchange surface for high efficiency. So fills are suspended on galvanized steel pipes for easy maintenance and effective evaporation. Also, our design is modular, so it ensures easier assembly and reduces site installation labor cost, only to have a connect upper box and lower box together. We have a detachable coil, which is very convenient for maintenance and efficient design for best drainage. The drift eliminators, we use high efficiency PVC drift eliminator to reduce entrained water droplets from the air discharge and save water. So in UAE, our distributor is Fluid Control Trading. The Fluid Control Trading is established in 2004 with objective of providing complete range of MEP solutions for HVAC plumbing under one roof. FCT also is the exclusive agent for Flowcon, Italy for static valves, and offering an extensive range of both manual and electrical valves. And FCT also provides control valves, PRVs, meters, thermostats, and other fittings and components for the HVAC industry. FCT is providing engineering solutions for all the various industries like HVAC, plumbing, district cooling plants, desalination plants, wastewater treatment, power solutions, horticulture, poultry farms, oil and gas. So these are some of the brands which FCT are having, and Mammoth and Rosemix are so proud to be associated with fluid control trading in UAE. Thank you very much. That's it for my presentation.
So our second presenter is also from the same group, I guess, isn't it? Mr. Philip Sarakan, the Chief Value Delivery Officer from Senior Project Management. Mr. Philip, are you there?
Yes.
Maybe can you switch your, can you mute your, yeah, you speak, okay.
Is it
Mr. Philip Sarakan, let me introduce you. He is, he enabled digital transformation of construction industry by integrating all project process and collaborating with relevant stakeholders during engineering, procurement, and construction. Please go ahead, Mr. Sarakan.
Thank you, George. I assume it is audible.
Yes, we can hear you.
Okay, thank you. Just share my screen. I trust you can see my screen. Can you see my screen?
Not yet.
Not yet?
Just coming. No, we can see you only. Still, we don't see your shared screen. Try it again. Philip's.
Yeah, I'm trying again. Can you see now?
Yes, indeed.
Can you see my screen now?
Yes. Yes, yes.
So I can go ahead. Okay.
Okay. We can see your screen now, well and clear. Phillips, we can see your screen. You can go ahead, please.
Thank you. We already heard a lot about technology, embracing the technology, digitalization and all, and talked about the equipment part and what is going to happen after the operations. I'm talking a little bit about the technology during the engineering, procurement, and construction phases. Especially it can be taken for any type of project and district cooling projects. These are the headlines we are seeing nowadays in the newspapers, in the medias. Gulf contractors face tough market conditions, cash flow, cash flow, cash flow. And this morning, this afternoon, we had a lot about cash flow. Is it the cash flow is the major issue, or profit, or both? We all know that both are interlinked. If the cash flows get delayed, then naturally the profit to have margin erosions and profit will be eroded. Quickly look into that. This is a potential cash flow. direction of the cash flow from the employer. Employer, it goes to down, main contractor, suppliers, consultants, specialist, direct appointment, then it tax, subcontractors further goes down. We all know that what is the net cash? It is nothing but cash in minus cash out. And here we are leaving the employers now at present because employers' cash flow, the revenue starts after the project substantial completion. For the once the project is substantially completed or even handed over, then their revenue starts. But the rest of the people, the revenue start during the project construction phase or engineering phase. So when we talk about cash flows, we had a lot today this afternoon. We also need to know, we all know who pays us. Main contractor know who is paying them, subcontractors know, the vendors know who pays us. But we also, it is very critical for us to know who funds these projects, because the cash flow is affected seriously if we do not know who funding them. Now we have talked about today the utilization, low utilization, overcapacity. If the funding is coming from the existing operational businesses, then we know that cash is going to affect. Quickly about the cash flow cycle. We know that from starting from the cash, existing materials order, payment terms, all these things, then when it comes to, we talk about the cash conversion cycle from when we pay to our vendors, then we talk about the rest of the cycle until we receive the cash. Especially when the project billing is critical, because every project, the billing is different requirements, substantiations are different, the documentations are different. So this is a very critical for the contractors and the engineering companies, others, to make sure the billing is submitted on time. Look into the cash flow factors affected, which are there is no limit to this. We can add a lot more. It's starting from the receiving advance payment until the withdrawal of the retention. So it can have any reasons. Maybe some of these are not applicable here, the strikes or vandalism in the sites, theft is happening in most of the sites. So except few of the items, everything is affecting our cash flow. What I've done is I've taken some of the cash flow issues, which the contractor can handle, or it is under their control. The reason why we've taken this, many of the issues, the COVID situation or funding from the source, it is not under the control of the contractor or an engineering company or not. But what we can do is we can look into some of the factors, whether the overhead expenses and value, keep this for the time being, keep the COVID away, think about a normal project which we are executing. Overhead expenses and value of preliminaries we can control. Receiving advance payment, make sure that requirement is done. Most of the cases we need an advance payment bank guarantee, make it is available. When it is coming to retention, many places we have egoistic project managers. They hold millions of dollars of retention just for few snacks which are now closed. Look into a cost benefit analysis and say whether we close this snack, how much we are getting it. Train them on cash flow. Cash flow is getting delayed for closing a few of the DLP period snacks. Then how do we handle liquidated damages, other damages, back charges, the front end and back end loading on the bidding. So all these, few of these things, we look into that. These are all under, most of the things are under our control. Many times delayed billing, it's happening in many places. Critical vendor payment, we don't pay the critical vendors, so vendor don't bring the services. I was speaking to one of my colleagues here saying that they didn't pay for the transporting agent for the transporting company, and 2,600 people outside, he stopped transportation. So 2 days they took to settle it, then 8 into 16 into 2,700 people, man-hours lost, and the bad name and brand image in the industry. So look into the possibilities of using a technology to address cash flow issues. I'm starting with engineering. So it is a typical district cooling plant, and where the hundreds of drawings, that is a deliverable for an engineering company. They make hundreds of drawings and they made the master deliverable list. Then it moves to the next stage. whether we are in the pandemic or we are even going to be after the post-pandemic, more organizations, the overall goal is to maximize the profit. And in order to maximize the profit, we need to see the new ways of reducing the cost. This high cost pressure is really affecting the engineering and construction industry. I've been worked with recently with the multiple engineering organizations. They have huge pressure. One best strategy is to collaborate and bring the contributing parties like in-house team. We have consultants, we have customers, vendors, we have outsourcing teams, we have freelancers. Bring all of them into a single platform and get their services and reduce the review times. And that is one way, collaborate. In a typical process, you take the deliverables, convert into a program, then engineering developers are developed. We already allocated what is a weightage to capture the progress. These are all done by manually. Then finally, you taken these dates, manually start and finish into the planned date here, and manually put the finish date also into your tracking sheet. So from the draw to IDC to IFR to IFC, you capture the progress manually. But in an improved version with automation, with a little bit investment, your WBS or deliverables are created in Primavera or MS Project or any other scheduling software or even Excel. Then it taken into a specific tool. I do not want to mention any tool's name. We can observe any tool which can automate it, and automatically it goes. Then you make the workflows, and each workflow, each status, we assign the progress rules of credit. Then the moment the draw is done, the next is going to checker. Then when the drawing has moving to the checking, then automatically progress captures from 30% to 50%, 50% once the score check is 70%, once approval is come 100%. So we can decide the workflows. And also to do list in each resources, we can assign a critical resources. We can give timing warning early. If he's working from another country, say in India or Brazil or somewhere else, we are using a freelancer. If that freelancer is doing work for us, we can give it in advance that notification that the drawing will be coming to you so and so date based on the schedule, because we are integrating both schedule and we are capturing automatic progress. The task is routed and resources know, and each position we know that we can give notifications. It goes back to the planning softwares for update, and we can capture anytime. It's a simple improvement. We can do it. This can be implemented in any documents, whether it is a drawing submittal, whether it is a method statement, material submittal, technical submittals, RFIs. We can use all these things. We can also enforce quality in this. We can have checklists in each stage. Each workflow stages, we can add checklist. If the checklist, we can put it mandatory if we get to stop the drawings, which will not go further. I mean, drawing means any documents. We can have improved automations. We can create transmittals. We can notify automatically. We can do it. We can also improve insert QR codes on the drawing. So once we do the QR codes on the drawing, anyone who is working, they just take their mobile phone, a free app, check the QR code, then they know that this drawing is the latest or not. If it is not the latest, the tool will give a warning stating clearly that this is not the latest drawing. Do you want me to download the latest drawing for you? So we know that many times the drawings will go on revising. It never reaches to the site construction proceeds, then rework happens. We can avoid such things due to simple techniques. It can be used with automation, a lot of 2D, 3D, 4D models. We can use it simultaneous or parallel commenting. Drawings can be commented parallelly. So multiple people or the subcontractor, the people on office, interdisciplinary team, different disciplinary teams, people from different countries, they can collaborate. up to 100 people, 200 people, whatever the number you wanted to collaborate. So the drawings can be collaborated and commented together. So that saves a lot of time. And automatically it creates a comment resolution sheet. So it creates a comment resolution sheet. Now you know that there is 30 comments. These 30 comments we need to address and change the drawing. So we can assign the people who is responsible, who has to do the next studies or any design changes required, they can do it. We can automatically improve the anytime we know the progress and where is the status. The drawing can capture the POQs. It can generate automatically the RFQs. RFQs can go to multiple vendors as pre-planned based on the workflow. And vendors can provide the prices directly into the tool. And the tool can compare and the engineer can review and approve which one to go and move to the procurement team. These are all few of the benefits. I just taken the engineering to start with it. So these are all existing for a long time. And COVID-19 forced to give a new momentum to collaborate remotely and extend virtual teams. We have seen this one. Most of us were working from home. To solve the problem of ensuring consistency across this extended virtual team that we had for less control than in-house team, organizations swiftly moved to the operations to the virtual space by setting up global online collaboration platforms. It is time to look into these global online platforms, which fit with our return of investment, what it is rewards back as. Now let's come back to the cash flow because of the limited time. When we have an integrated project monitoring and control tool, whether starting from engineering, from the procurement, then the construction, then we are constantly monitoring the progress. If the cash flow is going to affect, if you think that we are talking about a large chillers are coming in and the contractor is paying to the chiller manufacturer X works, and the progress reporting with the employer or the district cooling plant is coming in after installation or at place, then the contractor has to invest a lot of money from their hand. And if there is a float in the schedule, we can move the procurement process to the late start instead of early start. And we definitely need to do the analysis and risk, whether it get delayed, what is happening, the consequences, other things. But we can do all this because of the integrated project monitoring. Coming to most of the time, the cost is accrued in the project on a daily basis, but the cash flow is happening once in a month. We start with a smaller advance, and most of the time a contractor will be on the negative cash flow. And end of the day, if they are operating with a margin of 8% and a retention of 10%, most of the time we stuck with the negative cash flows. And an integrated project progress monitoring will again give an advanced warning that the cash flow is going to affect. So instead of going and taking getting funding at a much higher interest rate or in a distress mode or affecting the progress, the parties can plan in advance to get competitive funding. The retention is a real, I talked to a few of the people, they say that the biggest curse in the contracting industry is retention. Even in this case, we have here, we looked into the 5% of the retention is, I put it a small case for this presentation. 5% of the retention, that is 50% of the retention is coming back at the time of finishing the job or substantial completion.
May I interrupt? Can you conclude in 3 minutes, please?
Sure. Okay. If the retention get delayed, the cash flow is continued to be negative. It's an opportunity for an automated tool to say clearly that, yes, these are the snag resolutions sheet spending. Out of these snag resolutions, assign the cost, then see whether it is worth to do that and go ahead and get our retention back. If somebody wanted to look into that, and when we are managing a cash flow, a tool, an automated tool or integrated tool need to have minimum these data fields to enter, from a currency to cyclical events, leaves, other things, to effect of delays, how is the contingency and risk allowance spent included, LDs, whether it is a partial positions, how is going to affect our cash flows, if financing cost is going to happen. So the tool should have a minimum of these data fields that need to be captured in order to predict the cash flow. I'm just wanted to conclude. See, embrace the technology to deliver and control successful district cooling projects. I'm sure the technology is not the savior, but it is a catalyst. Look into that, and we thank you and love to associate with you in case you are looking for a solution. Over to you, George.
Right now, thank you, Phillips, first, and we move to 30-minute structured Q&A. We have, I think, around 27 questions received from you. Some of them, the early ones, were answered, I believe. But an interesting question that the new regulation in district cooling in Abu Dhabi helps the customer understand the added value of district cooling and establish rules to promote efficient district cooling, which is competitive vis-a-vis of standalone systems. You know, in Abu Dhabi, in certain areas where there is density, if you don't want to connect to district cooling, they are asking the owner to put a life cycle analysis to say why he is not connecting, making it more difficult to avoid connection to district cooling. This is what the question is and answer there at the same time. About automation and instrumentation, there is a question about how district cooling will use that and to integrate that into smart cities like in Singapore. I believe most district cooling now is using PLC-based industrial control and automation. Some of them are wary to connect them to internet due to operational security. Some of them has good protection and fire barriers to protect their control scheme. To integrate into smart cities that even in Singapore is not really done along with district cooling. And I think the future of district cooling is to integrate it with the whole energy mix, and especially when solar and wind energy are coming to play a major role. So we have to produce more cooling and more storage when solar energy is available. Question about the central gas network, unfortunately, is not there anywhere. That's why the restriction of tri-generation. Although there are some good tri-generation mix, particularly now we are seeing them more into remote projects that have a mix of tri-generation using diesel and solar energy that are integrated together with storage. A question also to Dominic. They are proposing that we can use UV lamps and fresh air handling unit as a solution for virus in lieu of to open windows. We have Tahniyat from Al-Bawardi Engineering. Is there any effort to make more district cooling competitive? And many are saying other question in the online, I mean, asking whenever we are bringing more central system, most often the end user was paying the price. And you heard me in previous presentations or seminars saying that why district heating succeeded in Denmark, because they made every house that connect to district heating will save 15% as compared to traditional heating system. As the same way, I mean, we have to structure our utilities to make district cooling more competitive. So district cooling, who buy in bulk, should pay the cheapest electricity, which also should be passed into the end user. Also in Dubai, where we are getting cheaper sewage treated effluent, much cheaper than fresh water, the saving of buying and using treated sewage effluent is not really passed to the end user. So we have these two factors that can really make district energy more competitive from ton hour or energy consumption point of view. From demand rate, our demand rate are quite competitive in the area. However, the connected load to these buildings are often double the actual load. And the district cooling utility is protected. They said we installed our system based on your design consultancy. So the regulation here need to step that at least when the district cooling get back their money in 7, 8 years or 10 years, the load should come down to the actual connected load and not the end user be overcharged forever for these more cooling. These are 3 items that can go there. Now, a question probably to smart energy. Dr. Ali, are you with us, or they are asking, does OCP have any
Yes, I am.
of
Yes,
AI or machine learning, artificial intelligence or machine learning? Does OCP has that or no? They are asking you.
Thank you very much. Yeah, OCP, you know, we don't want to overwhelm. There are trends, you know, we have to talk about machine learning. You have to talk about, you know, neural networks to be heard. Our way of approaching the problem is from the industrial side. We implement whatever is available in terms of mathematical modeling, in terms of physics, to get the savings. So if machine learning and so machine learning, so machine learning and supervised optimization are part of our portfolio of solutions. But what we care about is how do they apply to the real power, to the real plant, district cooling plants, and what benefit do they bring? So if they are bringing benefits, welcome. If they are not, we are completely agnostic.
Right now, so the answer is no. But are there
plans? The answer is yes. The answer is yes.
Right today, you have AI and ML?
Absolutely, absolutely, yes. Okay. The answer is yes.
Okay. A question also to you, probably. How we can control delta T with old control valves, especially in winter time?
So yeah, this question of delta T is we call this a syndrome. So it's really the problem of most of district cooling plants, and it has 2 components: from the distribution, from the chilled water distribution side, and OCP certainly has a strategy to look at each ETS and optimize the right overflow of chilled water distributed to ETS. But it has a component that is also, of course, from the customer side. So we need to work on both sides in order to make the delta T you know, stable over and independent of the load and of the usage. So yeah, there are a lot of methods. I don't want to enter into a lot of details here, but this is certainly one of the major questions that DCP suffers.
Okay, let's see from Armstrong. I mean, the question: why sensorless pumping systems are not commonly accepted, while these reduce first installation costs and lower maintenance? And the same person asking if this VFD is integrated with a chiller compressor is accepted, why not in the HVAC pump? What is the reason for this? Can you respond to that from Armstrong?
And I guess the first question was around centralist pump speed control, which is a technology that observes, it's a feed-forward control method. It observes the behavior of the load. And if the load is consistent in its behavior, it works very well. But if there are different behaviors out in the loop, so several buildings, then it's more difficult to ensure that every load is being satisfied. So temperature control, and this goes back to the prior question about delta T syndrome, is having a network system enables you to see the performance at every energy transfer station. So on district cooling, temperature control and knowledge is probably more informative than just flow and pressure. And that, I think there was also a question that you posed to the group on security and the access through the Internet of Things. And I think all of us would agree that for critical applications like district energy, district cooling, you want to have as much on-prem calculation.
और कैसा है? You attended today's meeting?
PB, could you please mute your mic? Anyway, we have also one last question regarding clarify how solar energy integration with district cooling can help the district cooling sector. Energy tariff are considering generation plant technology. Did you mean decentralization solar plant serving district cooling? No, actually, what I meant how district cooling can integrate with solar energy is that solar energy is produced during the day, while district cooling is working on load leveling with thermal storage being used to store at night to use it during peak. And the integration will reverse that, will make the district cooling to produce during the day and store during the day while solar energy peaks, and to use it during night where solar energy does not exist. Also, we're having nuclear power plants coming online, and we are having this energy mix. So I believe our base load will move to nuclear energy and solar energy, with the gas power plant will act as supplementary load or stabilizing load. And district cooling can play a major role in stabilizing our energy by producing when peak energy is there, and using thermal storage when we don't have as much as energy is there. That has been implemented in Saudi Arabia for a while, where they used to switch off the chillers between 1 to 4 p.m. and ask them to operate on thermal storage, like the Kingdom Tower in Riyadh. They have done it in a reverse way. Now, I mean, with solar energy as it increases, we have to find a better integration. This is what I meant. The question was to me.
Yeah.
If we go finally,
Mr. Chairman, do you want me to comment on the last aspect of energy mix and how
please.
demand response can be used in order to work on all this.
Dr. Ali.
Yeah. Yeah, I think every energy production system, whether it would be nuclear, solar, or traditional, has its pros and cons. For instance, nuclear energy will be bringing 1,400 megawatt of one nuclear power plant each. There will be 4 of them, so there will be a lot of benefits. But at the same time, the N-1 criteria for the network stabilization will increase all of a sudden. So the need for introducing stabilizing energy means in order to cope with incidents in the network in case of loss of the most powerful energy unit is very important. So demand response is certainly a very important role, and district cooling, especially when using the thermal storage, is absolutely key to take advantage of that. But that's a question purely of regulation, because today none of the countries of the Middle East is allowing that.
True. Thank you, Dr. Ali. And again, I mean, this repeated question about the benefit of district cooling, I mean, like Ibrahim Khan again asking, there is a common notion and sense that district cooling is expensive than standalone. If diversity factor is favorable to district cooling, so why is this situation in UAE? And again, regarding how the structure is, and I think I answered that before. Surrender, any question you think that I missed or from the Q&A?
Yeah, George, I see plenty of questions on pumps,
Yes.
which I'm sure we're very happy to pass on to Armstrong and others to answer. But if you wish, you could ask some questions on that. I also see a question on Btu meters.
Could you ask that? I didn't read it quite well.
This is by Salman Khan, and he's asking, do sub-metering Btu meters provide optimization operationally? Could you please shed some light on future of Btu meters in district cooling?
We see really a big increase in Btu metering, really an industry that's growing beyond our imagination. And we see, for example, Mcpolin has a subsidiary called Aqua Metro. Probably they went up just 12,000 Btu meter beyond their district cooling and not related to their district cooling scheme, with customers that they want to install them in buildings and asking them to do it as a service where they invest in a meter and collect service charges. Before you see presentation coming from Denmark, every time we have sub-metering installed, we saw reduction in usage of cooling energy by 15 to 20%. Of course, I mean, if it is metered, I mean, you try to optimize. It makes sense because you are being charged not flat, but on what you consume, and it adds consciousness to that from that aspect. But I can tell you today, probably there is close to 200,000 Btu meter installed in UAE alone. And that number is just going to grow, not to go less. Any further questions?
Yeah, there's a question from Kashif Javed, and it's probably directed at Dominic Mcpolin. He's using the word central system, but it could very well be referring to interconnection of reticulation networks. And he's asking if they are designed for efficiency and economical use. However, practically, it has not been observed. I mean, that's a question. Dominic, would you want to take that?
Yes. Look, our perspective, my perspective always is from the government side. We are interested in efficiency for one reason only, in terms of the sustainability and the other environmental reasons. At the bottom of the driver of this issue is cost. We have limited district cooling in Bahrain, but we have looked at the savings to the government if those plants are operating at full capacity, and it comes around 50 million dinars per year for no capital outlay by the government. It is a hard saving on gas, on primary substations, on cabling, on 11 kV. So the next wave that's going to hit all of us is the recession and the cost to government of covering COVID. Every single corner of every financial transaction will be searched for savings. Right now, district cooling to a government is an absolute godsend in terms of finding real savings as quickly as possible to get us out of recession, to get us back on our feet again, simply on the books of government. The efficiency is clear. The cost savings are clear to government. What we've got to do is to make the customer happy with what government wants to see happening. And one of the things I'd ask to say to George is one of the things that we've looked at and doing in Bahrain is to attack the overloaded capex for district cooling companies by allowing a cost sharing for the extension and for the setup and for for the increase in capacity in district cooling to come from the developers. They can't walk away with not doing their AC systems and their electrical mechanical bill and simply sign a piece of paper and dump the entire capex onto the district cooling company. We want to regulate a sharing of that saving to the developer into reducing the capex of the. Why? Because again, the government wants to see more district cooling faster, because it's very, very important from our national economic perspective.
Thank you. There's a question from Mubashir Hassan, and it's more of an observation really. It says, just sharing information due to restricted movement brought about by COVID-19, district cooling residential buildings are consuming 15% to 20% higher tons per refrigerated hour compared to their historical trends.
Surinder, we have seen, I mean, when we connect a building to district cooling, it gets supplied with constant chilled water temperature of 4 or 5 degrees. The fan coil and their handling unit will deliver slightly higher cooling capacity. We noticed also in some buildings that before connection to district cooling, they were switching off the air handling unit, the fresh air, or letting the chilled water temperature supply go up to 10 degrees, where the unit will not dehumidify, and typically that alone is 30% of the cooling load. So when district cooling goes, the 15 to 20% extra might be correct, but with it come much higher level of comfort, much better ventilation, much better control of temperature and humidity, because of better control of the supply chilled water temperature. Mainly, this is my observation as well, what I've noticed.
If you allow me, George, to add to that, I think we need to get our seatbelts on. I don't want to be alarmist about this, but the science is mounting that the circuit, we're all dispersed. As people come back to offices with closed circulation, you're going to find there's going to be a change in regulation where we're going to have to increase fresh air intake into our cooling systems. District cooling will be a very, very, very important part of that reaction. As we bring people back into denser populations inside buildings, commercial buildings that are designed with minimum ventilation, we're going to have to re-chill cold air. We cannot.
Dominic, we can mitigate that risk today. You know, we are having heat recovery wheel. If we select them properly and select good brands, we're getting 80% heat recovery efficiency. Yes. So we can allow better ventilation without really consuming big amount of power. Normally, I mean, we typically need 110 BTU per CFM for fresh air treatment. This can drop barely to 25 BTU with probably a bit more. No, we typically can reach 38 to 40 BTU per CFM of fresh air instead of 110. So we can have probably around 70%, you know, because we try to keep this building pressurized. We have 10% higher fresh air.
George, please correct me here. Sorry, please correct me here. I think it's better than using a heat recovery wheel. Again, it could be contamination of air because of the, you know, air coming back.
Circulation.
Don't you think ionization is a better way of, you know, improving the indoor air quality? I do appreciate Dominic is 100% right, because right now companies are working at 30% or 40%, what do you call this, occupancy. So when it goes to 100%, which I doubt, because now the working from home has become possibly a norm in most of the organizations. Mm-hmm. Maybe the indoor air quality can be improved by, I don't recommend UV because it has its own negative aspects.
Look,
could be
I have an experience where, you know, IAQ specialist visited my office. I alone was sitting in a big office, probably of 40 square meter, and have 2 windows that leak all the time. I was surprised to measure carbon dioxide of 1,000 ppm in my big office. So imagine people who are typically dense we are not having sufficient fresh air. This made me a bit sleepy. Every time I open windows in winter, I more freshen up and I'm more active. That's true also in schools and university and government offices. What you are saying about ionization and better filtration also play a very important role. But I believe that our carbon dioxide now has crossed in atmosphere 400 ppm already. I mean, already we have a high level there. And we need the ventilation rate really to respond basically to carbon dioxide level, and possibly the particles and viruses, we need to deal with them with better. We see now these small HEPA filter booming in supermarkets. We can bring them to our offices, maybe 1 or 2 in common areas that help really control viruses. And this, I recommend that with some better filtration in our system. And I agree with Dominic, better ventilation rate, really at least to control the CO2 level in our office space, preferably below 750 ppm. What do you think, Dr. Ali? Unmute.
I think the question of comfort is really to be taken into account in a global way, taking into account the temperature, but not only temperature, the fresh air, the carbon concentration, humidity, and all that stuff. But for that, unless there is a clear regulation in terms of building comfort regulation, I don't think this is going to be generalized. I think this question of comfort and energy efficiency, it's really a collaborative effort between regulation, imposing norms, standards, and things like that, facility managers who take care about the building side, and the district cooling. So we need to strengthen this relationship and to push all the system to work into the same direction, which is the comfort and the efficiency of the
in the COVID area now. What do you think of these portable HEPA filters? Don't we think each company or each offices should be at least adding 1 or 2 now to reduce or dilute the viruses and capture them more, rather than changing the whole HVA system, which we don't have control on? What do you think?
George, no one is ready to spend a single dirham. None of the...
True.
Okay.
But they are cheap, ready. Yeah, if you go to Carrefour today, you're talking about 1,500 dirham a piece, 2,000 dirham a piece.
George, I've seen offices not opening up just for spending 500 dirhams, if I'm right, 500 dirhams a day for sanitization. So let's see. One of the things we need to look at is a long-term solution, because this COVID is not going anywhere. We have to live with it. Let's accept it. So I think our job is to see, okay, as rightly you said, only 20% of the total AC system of Dubai is district cooling. Rest all is what we are going to do there. And one of the challenges, okay, if you talk of, Naik was speaking about the plant which is on the Sheikh Zayed Road. Of the possible, I think, of the towers there, hardly, I think around 20% of the towers are connected to the district cooling. Rest all are having their own. So what's happening here is there must be definitely a backward integration required. And okay, let's accept that the future capital investment may come to a bit of a stop for some time. At least we should look into in terms of spending the money on retrofitting and in terms of making those buildings acceptable for human living. In fact, a lot of these old buildings, if you see, pretty buildings, they lack fresh air. Let us accept it. It is absolutely below the required standards. So Dominic's point of ventilation makes a huge role in terms of guarding the health of those guys who are going to use these buildings for office or whatever is required. And coming back to the district cooling plants, definitely we need to have some sort of a unified effort in making them more acceptable to the end user. That is the bottom line.
May I interrupt, please? Because I'm sorry, but we have some more questions. Could I ask them, George, now?
Please.
One is related to heat transfer stations. And this is coming from Ibrahim Khan, who asks, is it common that heat transfer station is supplied by district cooling provider? And why not by the building owner based on the approved specs according to international standards? So that might give lower costs per unit basis. That's one.
Yeah.
And there's one more question. This has to do with pumps. There is a common notion in district cooling system that a vertical inline pump is not good enough, but conventional horizontal split case pump is more suitable, although conventional horizontal split case pump has higher maintenance cost. We need to have clarity on these in few lines here. Although in Europe and North America, vertical inline pumps designs are more preferred. So why not in the GCC region?
For vertical pump, we see them more common in the packaged chiller plant because really they provide big space saving. And we are seeing their use in some of the district cooling plant. The notion is there because there were slight difference in efficiency between horizontal split were slightly more efficient because the way they are laid or the way they are selected. From there came the notion. And also you can remove the upper portion and access the seal, while in vertical unit you have to remove the whole motor. And now they found a spacer. So really maintenance was resolved and improved for the vertical pump, and they are more accepted now. When it comes to energy transfer station being done by building owner, we notice that if the district cooling build their own ETS with their own PLC and controls, they have more a homogeneous system that they can control the entire system. When building owner try to do it on their own, they struggle with PLC and instrumentation, and they struggle to comply with the district cooling requirement, and it creates chaos and kind of a salad mix of plans and control systems that does not communicate with each other. I don't advise that the building owner builds their ETS unless it is done under the careful supervision of the district cooling company and in agreement with both. Anyone would like to add a comment? Anyone?
We see that trend also around the world with
responsibility.
I want to say something on ETS. Basically, ETS should be supplied by the utility provider because he maintains the water quality on his system. Whereas the building person will say you are contaminating the system. You see, it is like it's a boundary, a border defined between the two people, yeah? Now, basically, the district cooling has been discouraged because of the low delta T syndrome, and utility provider charges penalty as much as 35 to 40%. Empower charges 7% for every degree Fahrenheit drop. So the end user is penalized. You know why he is discouraged from using district cooling services? Because he gets a surcharge of 35 to 40% in his DIWA bill. Anybody can answer this question?
Thank you, PB. Thank you for that. Surrender, we are 5 minutes off. Shall we conclude it here?
Could I just ask one more question? This is coming from Ras Al Khaimah Municipality.
Okay.
From, Akshay Datta from Ras Al Khaimah Municipality asks, I would like to, and this question is to a representative of Tabreed. I'm not sure if there's anyone in the audience who's from Tabreed, but the question could be answered maybe by one of the participants here. I would like to pose to the representative of Tabreed in the webinar, what is the impact of Abu Dhabi's new district cooling regulation on new real estate developments? Are any cost efficiencies or energy efficiencies expected from it?
I answered that. I told you that they are asking you to do a feasibility study if you don't want to connect to district cooling. So they are kind of discouraging you not to avoid district cooling and really connect. So if you connect, you don't have to do anything. If you have opted not to connect, then you have to prove it by feasibilities and by number, and that can be challenged backward and forward. Frankly, I mean, when he talked about impact on development, any buildings that connect to district cooling, as Dominic was mentioning, he would reduce 8% in the construction cost. And Dominic wants that saving to be shared, not taken by the building developer, and then the district cooling will have higher charges. If that is shared, then the charges of district cooling can be reduced. Okay.
We have many more questions, but we have run out of time.
I think so. We are like 6 minutes behind schedule. I would like to thank you all, our panelists and our audience, for being
Mr. Chairman.
so active with us.
Lovely.
Thank you.
And as a concluding remark of today, this DC dialogue, I see the industry, I mean, if people invested 10 billion dirham in consolidation and are willing to invest more, our industry is lucrative and should grow even beyond that. There is a strong interest. Every time we bid out a district cooling scheme for sale, we see 5, 6 competitors willing to buy. So let's hope, I mean, this interest will grow and will develop, and one day before Dominic retire, we'll say, now we have a mature industry and it is integrated with everything else around us, and it's going in the right direction. This is my concluding remark as such, and thank you all for being there. I pass probably now the last call to Frederick. We want to thank all our sponsors. Thank you.
Thank you very much indeed, George, for a wonderful job again today. Thank you for your support, and I wish to thank as well our distinguished panel of speakers for joining us today and sharing their invaluable experience into the industry that they've been operating for years. And I'm very delighted to share with you that we've had delegates from 23 countries on this particular webinar today. So it is truly a testimony of, of a global reach for this medium. So thank you very much to all of you who have tuned in this afternoon to this from all over the world. Thank you to Peter, who is very far away, I believe. And thank you to all our speakers. Now I would like to particularly thank our sponsors, without whom this event would not be possible. So can you see the screen now?
Yes, we can, Frederick.
Very good, okay. So I would like to first and foremost thank our bronze sponsor, Armstrong, for its support. Also in our bronze sponsor category, we have Mammoth and Rosemex, and the distributor in the UAE is Fluid Control Trading, sorry. Then also in our bronze sponsor category, we have Smart Energy, and our strategic HVACR recruitment partner with us on board today, also carriersbay.com. Now, I would also like to, to take you through the upcoming webinars that we have for this month and next month. We have our third edition in the series of The Air We Breathe on indoor air quality, happening on the 24th of June at 3:30 UAE time. Then we shall be running another webinar on fire safety towards the state of calm, focusing on insight and recommendations on fire prevention and fire protection. Then on the 9th of July, we shall be running another webinar on business continuity and confidence building measures. Then on the 16th of July, we have another webinar scheduled on refrigerants, also a truly global event with participation from Brazil, US, and so on. Webinar on refrigerants called Refrigerants Review. It will be the 4th edition that we've conducted so far on that very topic. Then on to that, we move on the 19th of July on smart HVAC systems, particularly looking at the role of IoT in HVAC systems. And hopefully by the 15th of September, we shall be able to resume our physical events series in hotels. So we look very much forward to seeing you all in person this time, hopefully. With a mask, maybe or no mask, we shall see, depending on the government regulations. That will be. It will be the Client Consultant Contractor Conference, the 4th edition as well, to be held in a hotel. And at last but not least, our landmark event, the 10th Annual Climate Control Awards 2020, which will happen on the 24th of November, again in Dubai. So again, I would like to thank all of you, our speakers, sponsors, our attendees, for making this webinar extremely successful today. I hope it's been a very good experience in terms of learning, and that we managed to answer some of your questions. Back to you, George. Thank you very much for your help.
Thank you. Last thing, Surinder, will the audience will have access to all these presentations?
That's correct, George. We're going to upload all the presentations on the dedicated webinar platform, and also on our climate control, www.climatecontrolme.com. ME stands for Middle East, so climatecontrolme.com. So all the presentations will be there.
Okay. So we conclude today.
Yes.
And we thank everyone, and we hope to see you soon with a more vibrant industry that will always grow and flourish. Thank you, everyone. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.